Kia ora tātou, welcome to this video where we will look at substitution reactions. So there's just three substitution reactions that we need to know. So the first one involves alkanes, so when an alkane goes into a haloalkane. And this requires a halogen. You might be able to realize that because we're turning an alkane into a haloalkane, so the halo has to come from somewhere. So the halogen is any group 17 element, so it could be bromine or chlorine. Often it's bromine, so aqueous bromine that would be used. So if in a solution of bromine, you wouldn't have it open to the air because it smells like nothing else. But that is, and I'm not going to be able to get a good color, let's use yellow, but the bromine is an orangey brown. Okay, so we have the bromine solution, we would add that to an alkane, and what we would get is that this alkane, which will have hydrogens all around it, will be substituted, and I'll make this a red one of the hydrogens will be substituted by one of the bromine atoms. So we're going to end up with one bromine on there, and then the rest of the hydrogens stay in the same place. So that means that what we've got left over is one more bromine and that hydrogen there as well. So we would have HBr. That's just for your interest. You don't actually need to remember that. So this one, yeah, the color change will go from, because of the bromine water starting off as orange, what you would observe is an orange color going to colorless. And this doesn't happen straight away. So what we need is actually UV light. So for this reaction to happen, it needs to occur in UV light, and it's reasonably slow. So you would add the bromine to the alkane, put it in UV light, so in the sun, and gradually that would turn colorless. So often this is used as an identification question where we would have an alkane compared to an alkene. How would you tell the difference between them using bromine? And so with an alkene, the bromine will go from orange to colorless straight away, whereas with the alkane you need UV light. So you can use that to answer an identification question for that. So the next one, and I'll make some room, we'll get this down there, is alcohols. So alcohols can turn into a haloalkane. So I guess much the same as the alkanes going into a haloalkane. But the three reagents that we need to know for this, and just remember one of them if that's helpful, is PCl3, PCl5, or SOCl2. So if you're able to identify, it might give you the reagent and would say an alcohol reacts with one of these reagents, what will it turn into? And so the one chlorine atom is going to be substituted for the OH group on the alcohol, and that will turn into a haloalkane. So an example of that could be, if we're just using a 2-carbon molecule, and we've got OH group there. If we react that, and I'm just going to choose one, let's go SOCl2, the organic product is going to be, instead of the OH group, we're going to have a Cl, and then we'll have hydrogens around the rest of it. So you basically always only need to know the organic product, so the organic product being the product that has the carbons in it. So we don't need to know what happens with this SOCl2 or what happens with the OH. We just need to know that the organic product will be this chloroethane. So that could be SOCl2, PCl5, PCl3, they all do the same thing. They will substitute that OH group for a Cl group. Okay, and then the last one is a haloalkane. So a haloalkane can turn into an amine. So this is the only way that we learn to make amines. So that's an important reaction. So if you see an amine and there's a question asking how to produce that amine, you would need to start with a haloalkane, and we would use alcoholic ammonia. So that just means ammonia dissolved in alcohol, ethanol really. So the example could be, if we just still use this this 2-carbon molecule, so we've got chloroethane, that would react with the alcoholic ammonia, and the NH2 will join in on the end there, so we'll get NH2. So we need to lose a hydrogen because otherwise that would have an extra hydrogen, and nitrogen only makes 3 covalent bonds, except that could gain a hydrogen and turn into the ammonium ion. But basically for this first reaction, yeah, we'll lose one of these hydrogens, so we're going to get H, and we're going to get this Cl as well as another product, but just for your curiosity to know what else happens. And then the rest of the molecule will be surrounded by hydrogens. So that's the third substitution reaction. So substitution is when one group is substituted by another. So we're not creating a double bond, we're not breaking a double bond, we're just substituting one of the groups. So we've got alkanes, alcohols, and haloalkanes that can all undergo substitution reactions. Hope that helps. Look forward to seeing you for the next video. Thanks very much.